Hi, I'm Miguel Mendoza, Senior Marketing Manager for the Analog Power and Interface Division here at Microchip. Today I'll be demonstrating Microchip's ultra power efficient ceiling fan. Ceiling fans have been widely used in homes, businesses, and industrial facilities to circulate air and to maintain comfortable room temperature, working in tandem with centralized air conditioning. In developing countries, ceiling fans are only means to keep the room temperature cooler than the outside temperature, especially in areas where the temperature can exceed over 40 degrees Celsius. These fans are driven at very fast revolutions per minute to maximize the cooling effect. More than one fan is used in one room, and they run them 24 hours a day. These fans are typically AC fans, which draw around 100 watts per fan. What if there was a fan that can do the same work for a quarter of the power? Yes, 25 watts. Let me demonstrate. I will start with 100 RPM. You can see how this fan only draws 3.2 watts at this RPM. If we increase the RPM to 200, this only draws 15 watts. If we increase the fan at 300 RPM, this fan draws 25 watts. This is about as much power you need to power an LED bulb at home. You may ask, how is this possible? This is using a brushless DC motor, which is a DC motor that requires an electronic commutator, which requires an active device such as a microcontroller, a power stage to drive the motor, and power management devices to regulate power, and the connectivity devices. The DSPIC33 is a 16-bit microcontroller that features a 70 MIPS DSPIC DSC core with integrated DSP and enhanced on-chip peripherals. These DSCs enable the design of high-performance, precision motor control systems that are more energy efficient, quieter in operation, have a great range, and extended life. Connectivity is demonstrated on this board by the use of the Microchip's MICRF220 receiver and MICRF112 transmitter. If you look closely, you can see the PCB antenna is a PCB routing that's perfectly tuned to get the best reception, even though it's in a metal case. In this example, the RF transmitter transmits at 433 megahertz, assuring the range to exceed 20 meters, even with the receiver antenna being inside the motor casing. There is a MIC38AC44 AC to DC controller that converts the line AC voltage to 24 volts DC. This circuit uses a flyback topology that is low cost and very efficient. We also implemented a passive PFC to keep the power factor above 0.9 even at low power conditions. In this fan, the DC motor runs on 24 volts, making it an easy adoption to run from solar panels compared to the high voltage motors. The motor commutator is a 3-phase power stage that is controlled by a DSPIC33 microcontroller. The power stage is a circuit that uses 3 half-bridge MOSFET drivers, such as our 85-volt MIC4605 shown in the circuit, and 6 MOSFETs to perform the 6-step commutation. The MIC4605 85-volt operating voltage allows the flexibility to use 48-volt, 36-volt, or even a 12-volt motor. The MIC4605 MOSFET driver does need a bias voltage to drive the MOSFETs. In this design, we used a very popular 4684 switching regulator to provide a 12-volt DC voltage to assure we get the lowest RDS on from the MOSFET and ensure the highest power efficiency. The MIC4684 is a synchronous buck regulator with internal MOSFETs and adjustable current limit. The current limit allows us to use the smallest inductor to keep the BOM cost as low as possible without any concern that we will drive the inductor into the current saturation threshold, as we can limit the maximum current. The DSPIC33 microcontroller draws very low power with a 3.3 supply voltage, which can easily be driven from the 12-volt supply rail using our MIC5235 LDO. The LDO requires a very small footprint and only requires an input and output capacitors. The MIC5235 LDO also offers reverse current protection and polarity protection. This is only one example of many applications that utilize a complete ecosystem offered by Microchip. Most of the same circuitry can be used for e-bikes, kitchen appliances, heating, venting, and air conditioning, and many other motor-driven applications. Microchip can offer the product and support for you to design your low-power, low-cost appliances. For more information on this demo, please visit microchip.com. Thanks for watching.